Hi there guys, and welcome to this video on solving equations with indices. Now, before we start, I'm going to ask you a few questions that are imperative for you to understand if this is going to be successful. So, everyone knows that's 25, right? Some of you might have been thinking 10, you're just not thinking enough. But 5 times 5, 5 repeated by itself is 25. So if I set up an equation, I've got x's, I've got equals, so I've got an unknown, that's an equation. So I think you'd agree x must be equal to. And the reason I know that, if you're unsure, is this side has to equal the right hand side. That we're told that by this equal sign. So 5 raised to a value 2 is equal to 5 raised to another value. So these values must be the same. For example, I could write it like this. That has to be the same. I could never ever say that is equal. It wouldn't make any sense. So once we have the bases the same, all we do is just compare the powers, the index values. Let's have a look at another one. So I need you to understand this. So if I present the problem to you with a power to power, what can you do with those powers? There's a little shortcut, if you know it, and it's 3 to the power 6. And the reason that works is because that's 3 squared times 3 squared times 3 squared, because we are multiplying this by itself 3 times. And we can add those powers, or it's 3 times 3 times 3 times 3 times 3 times 3. The 3 has been repeated 6 times. So just for your own benefit, if I did this, what would it be? 14. Multiply the powers is the shortcut, or you can write it out in full. It takes a long time, especially when there's 7 of them, but just times the powers together. What else do you need to know? Well, it'd be very helpful if you understand what this means. Loads of different ways of approaching this, but what I do when I see a negative, I reciprocate my value, and that is now a positive power. That's for another video if you don't understand why that happens. So then I'm just timesing the numerator and the denominator by itself 3 times. So 1 cubed is 1 and 5 cubed is 125. So if you ever see this 1 over, it's been reciprocated, you have a negative power. And just so you're fully confident, if I had 4 to the minus 2, that's the same as 1 over 4 all squared, which is 1 over 16. Okay, let's go. So here's a question for you. 9 to the power of x is equal to 3 to the power of 4. So this is a pretty rubbish question, to be honest, because 3 to the power of 4 is 81 and 9 squared is 81, so you know that's a 2. But you might not have been that comfortable with this. But if you think back to the first one, I'll just go back to it quickly. The bases were the same, and with all index values, we're only interested in the bases are the same. So when you approach these equations, if the bases are not the same, you have to make them the same. And always look, can we keep everything as this base? So yeah, 9 can be written as 3 squared. So that is an equivalent statement. Yeah? 3 squared is 9, 3 squared to the x is the same as 9 to the x. Now we have the power to power rule, and the shortcut was to multiply them. So I end up with this. 3 to the 2x is 4, and therefore I know that 2x equals 4, so therefore x must be equal to. Let's have a look at a slightly better one. Let's go 9 to the x is 27. Oh, let's do x plus 1, why not? Now, hopefully I just paused that. So 9, well, I can't raise 9 to anything and get 27. That's not quite true, but I'm thinking of an integer value. So I'm going to have to change both of them. And you can see if I write this as a base value of 3, I can do that. And this is 3 cubed. So it does help if you know your powers and your base values. So now I have this situation. So power to power, so times the powers. And again, times the powers. Be really careful here because there's 2 terms. So it's 3 lots of this. So that's 3 lots of 3x plus 3. Now I can just compare the powers. So 2x must equal 3x plus 3. X is on one side, numbers on the other. So when we put minus 3 in here and here, they're equal. Let's have a go at another one. Let's go for, I'm just thinking out loud here. So let's go 25x plus 1 equals 125 3x minus 2. Let's see what this does. Okay, so 25, if I raise that to another power, I get 625, so I've obviously gone past. So I can write both of these as a base value of 5. This is 5 cubed. So pop the powers on, and now we're going to apply our power to power law, so we can multiply the powers. So we get 2x plus 2, and just be careful, you must multiply every term by 3, so I've got 9x minus 6. Compare the powers, so 9x minus 6 must be equal to 2x plus 2. Then most x's are on the right, so I'm going to collect all the x's on the right hand side, subtract 2x from both sides. The number terms need to be on the left, so I'm going to add 6 to both sides, divide by 7, and there we go, 8 over 7. Now let's just try one more. I'm going to make it, or 2 more actually. So if you end up with this situation here, we've got 3 to the power of x is equal to 1 over 9. 1 over, I'm thinking negatives. I'm looking at that and thinking that has been reciprocated. Now, I need to think about the same as before. The base value has to be the same. So now I'm here. So when I look at this, I'm thinking it has to be a minus 2. Minus because I can see this 3 has been reciprocated, and yeah, that's it. You just got to know your power laws, your negative powers. Let's make that a bit harder. Let's go for 16 to the x is equal to 1 over 64. Both can be written as a base value of 2, but both can also be written as a base value of 4. So I think about another way of doing this actually. So instead of just keeping it like this and looking, what I could have done is written it like that. Because the 1 over 4, if I reciprocate that, I get 4 over 1, and then my power would be negative. And if I do the power to power law here, I get this. It's probably a definitely easier way of doing it. Probably, definitely, that doesn't make any sense. So 2x equals minus 3, so x is equal to minus 3 over 2. So that's solving equations with indices. Now it's time to practice. And hopefully you were thinking, well, what if this can't be done? What if you can't have the same base value? Well, sit tight. You're going to wait a little while for A-levels, and it's called using logarithms.